Today we're going over end behaviors of polynomial functions. So polynomials are characterized by their degree, which is the highest exponent of a power of x. So just let's take a look at these graphs and what they look like and see if they have any like common things behind them. So if you have something of degree 0, that means you have a constant. That would be like a number 4 or like y equals 9. In that case, like you would write a straight line that goes like this. So if it has a degree 0, it's just straight, okay? That's going to be the only weird one. Outside of that, they start doing pretty much the same thing. So notice that something of degree 1 is going to be like a line. That's kind of like y equals 3x plus 2. Notice that it has an exponent of 1 as your highest exponent. And in that case, you're going to have some kind of line. It's either going to be going up like this, or it's going to be going down like this, depending on whether your slope is positive or negative. More importantly, though, I want you to notice that on one side, it's going one way, and on the other side, it's going another, okay? Once you get something to degree 2, we call it a quadratic. Your quadratics, we've been working with those a lot. Notice that they look like this. They look like U's, right? More importantly, I want you to notice that on one side, it's going one direction, and on the other side, it's going the same direction, okay? When we get to degree 3, we have cubics. Cubics have this like little weird squiggly shape. But more importantly, I want you to notice that on one side, it's going one way, and on the other side, it's going completely opposite. So hopefully you start seeing a pattern. Here's a quartic. It means it's degree 4. That means you have something kind of like this. But more importantly, your biggest exponent is 2. Your biggest exponent is 4. And then look what happens here. You got this really weird squiggly again, but more importantly, on one end, it's going one way, and on the other end, it's going the same way. So once we get the 5 one, you got, again, some weird squigglies, but on one side, it's going one way, on the other side, it's going the other. We call those last things end behaviors, okay? So end behaviors of a polynomial function depends on its degree and the sign of the leading coefficient. This is called the leading coefficient test. So what I want you to notice, I want you to recognize a pattern is when you have, except for this one's kind of weird, right? But outside of that one, and even that one, I guess, but outside of that one, the odd ones, this is an odd, this is an odd, this is an odd. Notice that on one side it's going one way, and on the other side it's going another, okay? So they do opposite things on the odd functions. On the even functions, the ones that have even powers, they're both going the same way, right? They're both going up, they're both going down. I guess in this case, they're both going sideways. So that's pretty much what we're going to be writing. So here's what we're going to do. We're going to start memorizing these first two. And we're just going to give you a generalized pattern. If it has an even degree, even degrees are both going to go the same direction. And normally, they are pointing up, okay? If you have an even degree. So if I were to tell you something like x to the 8th, then I'm going to tell you they're going to be ending up in the same direction. It's going to do some weird stuff in the middle. I don't know what's going to happen in the middle. But I know they're both going to end up pointing in the same direction because I have an even powered degree. If you have an odd degree, they're going to be pointing in opposite directions. So if you have something like this, it's going to do some weird stuff in the middle, but who cares? It's going to start off in one direction, going one way, and it's going to go in a completely opposite direction, going the other. Now, the order matters. So for even degrees, we're going to say that these are normally pointing up. For odd degrees, we're going to say that normally it points down to the left and up and to the right. Normally, I would be showing you my fingers and saying like, oh, 2 up, and then left hand down, right hand up, when you're doing stuff like this, right? So that's for regular positive leading coefficients, and I'll show you what that means later. However, if your first term, your leading coefficient, is negative, then it does the exact same thing that we've been teaching you this entire time. A negative is going to flip your graph. So a negative in the front, if you have an even powered degree and you have a negative in the front, then what's going to end up happening is this thing that was pointing upwards is going to flip. Now it's going to be pointing downwards, okay? Same thing with this one. Let's say you had this graph, but now you have a negative in the front. Well, it's going to flip it. So instead of first pointing down and then pointing up, then you're going to completely flip it, and now it's going to first point up and then point down. I know that's a lot of stuff going on, but just we'll worry about this as we move along, and you'll start learning this. But the most important thing, guys, is you have to remember these guys here. So even degree, I'm going to do this in green. If it's an even degree, they're going to both point up. If it's an odd degree, it's going to start pointing down and it's going to end pointing up. That's assuming your coefficient is positive. But if your first coefficient is negative, then it's going to do the exact opposite, so the stuff's going to flip. Instead of both pointing up, they're going to turn to both pointing down. Instead of pointing down then up, then it's going to point up then down. Okay, the negative just completely flips whatever's happening. We'll talk about these translations in a little bit, and we'll fill these out as we move along. Let's just kind of get the gist of what's going on here. So example, determine the degree, the leading coefficient, and the end behavior of each polynomial. All right, so here's what we're going to do. We are going to look for the degree first. Remember, the degree is the largest exponent. This is not written in standard form. So I'm going to look for the degree. That's going to be the biggest exponent that I have, and I see that the biggest exponent is 10. So I'm going to say that this thing has a degree of 10. Once we figure out that it has a degree of 10, then we're going to say, all right, if it's a degree of 10, then this is an even degree. That's important because since it's an even degree, I know I'm starting off in this case right here, right? I know both of these things. I don't know what's going to happen in the middle. Some weird stuff is going to happen in the middle of my graph. But I know it's going to end going up to the right, up and to the left. Okay, and I'm just going to leave the middle blank because I don't know what's happening. However, the next thing I'm going to do is, all right, since it's an even degree, then this one should be written first. And this is my leading coefficient. And I want you to notice that this leading coefficient is negative. So because the leading coefficient is negative, I'm going to write leading coefficient the first time. And then after that, I'm going to change it, okay? Leading coefficient is negative. So I need to flip my graph. Instead of it pointing both up, now these are both going to point down. Again, I don't know what's happening in the middle. I just know I have an even power, so it's going to be two going in the same direction. And because it's negative, instead of both pointing up, they're going to both point down. And some weird stuff is going to happen in the middle. But I know the end behaviors are going to do something like this, okay? All right, I think I got most of it. Yep, so determine the degree is 10. The leading coefficient is negative 20. I didn't write that one. I'm realizing I ran out of space. I should be a little bit more conservative with my space here. In fact, let me go ahead and split this up. All right, here's the last thing we need to talk about. Notice that we have all this extra space down here. That's because we need to start translating some of these statements. So let's see. On the homework, they're going to be asking you like, hey, what happens as x approaches negative infinity? What happens as x approaches infinity? Does f of x approach infinity? Does f of x approach negative infinity? So let's translate what this means. When they say as x approaches negative infinity, I want you to think of like a graph, right? Notice that your x's are here and your f of x's are here. What they're saying is as x approaches negative infinity, well, these are your x's, and negative infinity is this way. So what they're saying is as x is going this way, which is really a fancy way of saying as x approaches negative infinity means as x goes left. As you go left on your graph, okay? Similarly, when I say as x approaches infinity, again, here are your x's, and now my x's are approaching infinity. So that here's infinity over here. This is a fancy way of saying as x goes right. All right, so I know as x approaches negative infinity means as x goes to the left on your graph. And as x goes to a positive infinity means as x goes to the right on your graph. F of x approaches infinity. So what does that mean? Let's see. Again, here's your graph. Here are your x's. Here are your y's, but y's are the same thing as f of x's. So when they say as f of x approaches infinity, so here are my numbers going to infinity. Here are my numbers going to negative infinity. So this f of x approaching infinity, that means that your y values are going up, okay? So f of x approaches infinity, you're going to translate this as saying your y's go up. Similarly, when you say f of x approaches negative infinity, f of x is just a fancy way of saying y. You're going to say your y's go down. Why are we writing all that? Well, this is a fancy way of writing exactly what's happening on your graph. So let's describe what's happening on your graph. Look at your end behaviors. What happens when you go to the left on your graph? As x's are going to the left, so I'm going to write as x approaches negative infinity. This is a fancy way of saying as my x's are going to the left, what's happening to your graph as your x's are going to the left? Well, it looks like your graph is going down, right? So you're going to say as x approaches negative infinity, your f of x's, your y values, go down. How do I say go down? It goes to negative infinity. So this is describing what's happening here. In fact, I'm going to highlight this first part. As x approaches negative infinity, f of x approaches negative infinity. This is saying this part right here. Now let's talk about the other part. As my x's are going to the right, what's happening to my graph as my x's are going to the right? All right, I'm going to go ahead and write as x goes to the right. Remember, x approaches infinity. So as my x's are going to the right, it looks like my graph is still going down. So I'm going to say as x approaches infinity, my y values, which is my f of x's, approaches negative infinity still, right? It's still going in the same direction as before. All right, that takes care of the first one. I know it's a lot of new vocabulary, but honestly, it's really not that tough once you start getting the hang of this, okay? And I just realized that this is going to need more space, so let me go ahead and do some weird surgery on this thing. Let's do something like that. That way I have more space. There we go. All right, next one. I got negative x cubed, negative 7x squared, plus 8x, and plus 2. I want to know what are the end behaviors of this thing. So the first thing I need to figure out is the degree. Let's see, what's the biggest exponent here? My biggest exponent is x cubed. So this has a degree of 3. And since it has a degree of 3, I know that this is an odd power degree. Since it's an odd power degree, I know that on the left side, normally it goes down, and on the right side, normally it goes up, okay? What's my leading coefficient, though? Well, let's see. Since this is my degree, then this is my leading coefficient. My leading coefficient is -1. Leading coefficient equals -1, which means my graph is going to flip. So normally, if you have an odd power degree, it starts low and it goes high. However, because my graph is going to be flipped, it's going to do the exact opposite. It's going to start high and then it's going to end low. All right, that should be my graph. And I think, yep, I think this is okay. Remember, I know that this flipped because I have a negative, right? So what does that mean? Let's see. Let's talk about this as it relates to using these fancy words over here on the right-hand side. Let's see what happens as I go to the left on my graph. As I go to the left on my graph, what's happening to this graph? It looks like it's going up. So let's see. As x, how do I say goes left? As x approaches negative infinity, as my x's are going to the left, what's happening to my graph? My graph is going up. So I get to say my y's. My y's, I'm going to write f of x approaches, and since it's going up, I'm going to say it's going to positive infinity. And, by the way, that's the left side of my graph. For the right side of my graph, I'm going to say as x approaches positive infinity, that's the way of me saying as I go to the right, my x's are going to infinity. As x approaches positive infinity, as I go to the right on my graph, what's happening to my y's? Well, my y's are going down. So I'm going to say my y's, I say f of x approaches negative infinity. That's me describing the green part of the graph. Again, I have no idea what's happening here in the middle of the graph. I just know how my graph is going to end up. Okay. All right, last one. I got x to the 5th minus 7x plus 8x to the 8th plus 10x. We're going to go ahead and highlight the degree. The degree is 8. So I'm going to say my degree is equal to 8, which is even. Since it's even, I know I have something that's doing this, right? Their even powers look something like this to start. I'm going to look at the leading coefficient. The leading coefficient is a positive 8. Because again, if I write this in the correct order, this one would go first, okay? So I'm just going to write L dot C for leading coefficient. My leading coefficient is a positive 8, which more importantly, it's positive. Since it's positive, it is not going to flip. So my graph is actually going to end up looking like this. It's going to be both arrows going up. All right, no flipping in this one. So therefore, let's go ahead and write down what's happening. As my x's go to the left, what's happening to this graph? Well, my graph is going up. So as x approaches negative infinity, that's saying as x goes to the left, then my y values, which is f of x, approaches positive infinity. It's going up. This is the first half of the graph right here. And then to describe the second part of the graph, as my x's go to the right, as x approaches positive infinity, my f of x's, my y values, are going up. That's describing this second half of the graph. Okay, hopefully that made sense and you don't have any questions. If you do, you can always ask. So feel free to ask whenever you want. And that's it for the video.